The first step, if you haven't already, is to download the Arduino software. So to do that, head to your browser and go to arduino.cc. There, on the website, go to Software, Downloads, and then scroll down to download the Arduino IDE. Pick your operating system and click on the download link. Here it'll take you to a donation page, but you don't have to donate to download. The software is free. Just click Just Download and the software will begin to download. Once you've gotten that started, go ahead and finish the download and install the software, and you'll be ready to go. Alright, so the first step is going to be connecting your Arduino to the computer. So first pull out your Arduino and your USB cable. If you have a new Mac, you may need a USB to USB-C adapter. So once you plug it in, the Arduino should light up. The next step is in the software. Once you've downloaded and installed the Arduino IDE software, you should see a window that looks like this. Now this is an introductory class and we don't expect you to have any programming skills. Hence we don't expect you to write your own programs. What we want you to do is to be able to look at other people's code and figure out how to change it to your purposes. And we've got tons of TAs here to help you if you have to modify code. To start, we're going to look at an example code that will flash the built-in LED on the Arduino. You can find that code by going to File, Examples, Basics, Blink. You can see this opens up a piece of software written by Arduino that will flash a built-in LED. To run the program, we have to load it onto the Arduino. The first task is to tell the computer where the Arduino is. To do this, we click on Tools, and then check that our board says Arduino/Genuino Uno, and then go to Port, and pick the device that says Arduino Genuino Uno. Now I don't have an Arduino connected right now, but if I did, it would appear here. Once I've selected that device, I can come here and click Upload, and the code will upload to the Arduino. So once we hit Upload on the software, we'll see on the Arduino the TX and RX lights will flash as the software uploads, and then the LED built-in should start blinking. The next step, once we get this to work, is to build an external LED circuit. For that, we're going to need our breadboard, our jumper wires, and our electronic components. Let's review how the breadboard is connected inside. The main area of the breadboard is connected row by row. Each numbered row, all 5 holes are connected together with a wire inside the breadboard. On the ends, we have 2 power buses for positive and negative voltage that are connected all the way down the line. People typically use these for large circuits that need connections to power and ground in a lot of places. What we're going to want to build is a series circuit with an LED followed by a 1 kilo ohm resistor. The LED, when current flows through it, will light up. The resistor limits the amount of current that can flow. 1 kilo ohm is sufficient to let the LED light up, but not burn out. Okay, so let's get our LED and our resistor. The LED, it matters which direction you plug it in. The long lead needs to be on the positive side. So what we're going to do is put the LED in the breadboard and use one of our jumper wires to connect the long lead to one of our digital pins on the Arduino. I'm choosing pin 9. The next step in this circuit is to insert the series resistor. This needs to go on the other side of the LED from the connection to the Arduino. And then on the other end of the resistor, we have another wire going from the circuit board, this time to the ground pin on the Arduino. This way we've created a complete circuit. When we turn on the power in software to pin 9, current will flow from the pin through the LED, through the resistor, and back to ground. And the resistor prevents too much current from being drawn, protecting both the pin and the LED from burning out. The next step is modifying the code to flash the LED connected to pin 9 instead of the LED built onto the board. As you can see, several times in the code, LED built-in is used. If we want to flash the LED on pin 9 instead of the built-in LED, we simply change LED built-in to 9. Once we've made the changes, we can upload the new code to the Arduino. And once the upload is complete, instead of flashing the built-in LED, our LED on the circuit board should flash. For your sign project, you'll need at least 2 LEDs, so we're going to go ahead and add a second LED circuit. Once again, we have to connect the LED in series with a resistor between a digital pin and ground. This time I'm going to pick digital pin 8. So let's start out with an LED, place it on the board. Once again, the long end of the LED is positive, so we'll connect that one to our digital pin. The other end needs to be connected to another 1 kilo ohm resistor. And we already have a connection to the ground pin on our circuit board, so we don't need to run another wire to ground. We can instead share a wire between both circuits. Hence, I'll plug the other end of this resistor into the same line as the ground from the first LED circuit. Now, once again, we need to modify the code to flash 2 LEDs. You can probably guess which lines are important in turning the LED on and off. What we're going to do is copy and paste those lines and then change the pin number. This line here turns the LED on, so let's add a line to turn the LED on pin 8 on. This line turns the LED off, so once again we'll add a line to turn the other LED off. This line up here is also important. It tells the Arduino that pin 9 is an output pin, so without it, these lines down here will not work. Once again, we'll copy and paste it and then change the number to work for pin 8. So once we've finished modifying the code, we can upload it, and once that's complete, we should see both LEDs begin to flash. Okay, so we've gotten both LEDs to flash, but what if we want them to alternate which one is on and which one is off? That should be pretty easy to do. You can see in the code, we turn both LEDs on, wait a second, then turn both LEDs off. All we need to do is switch the lines that turn the LEDs off and on for one of the LEDs. To do that, I'll just rearrange the lines of code and voila! The program now starts by turning the LED on pin 9 on and the LED on pin 8 off, then waiting a second and switching which LED is on and off. Let's go ahead and upload it and see what happens. Now, once we upload the modified code,
the LEDs should begin to flash in an alternating fashion. The one other required component in your sign is a push-button circuit. This circuit is a little bit more complicated than the LED circuit. For this circuit, what we need is one pin of the Arduino is connected to one side of a push-button. That same side of the push-button is connected to ground through a resistor. The other side of the push-button is connected to 5 volts, and this way, when the button is not pushed, the detection pin on the Arduino goes to 0 volts thanks to the connection to ground through the resistor. But once you push the button, the detection pin is connected to 5 volts through the button, changing the detection from a 0 to a 1. Alright, let's go ahead and build the circuit. The first component we need is a push button. Now, you'll notice this push button has 4 legs. There's really only 2 connections on the push button. This wire and this wire are connected together inside the plastic casing, as are this wire and this wire. So when we build our circuit, we'll connect our components for one side of the push button here and our components for the other side of the push button here. We'll put the push button on the board here and start building our circuit. The first thing we need is a connection to a detection pin. I'm going to choose pin 2. So, plug in there and we can pick either side of the push button. It doesn't matter which side we use. The next step is to set up the resistor connected to ground on the same side of the push button as the detection pin. It doesn't matter what resistor you use, so in this case I'm going to use a resistor with the color code brown, black, orange. Connect that between our push button, and then because ground is kind of far away, I'll use an additional wire to get there. Now we need to connect the other side of the push button. This side is very easy, it just goes straight to 5 volts. Once again, there's a 5 volt pin on the Arduino itself that we can use. So plug it in on the Arduino and plug it in on the push button. Alright, now that our push button circuit is complete, we need to do something in the code to have the push button control the LEDs.
First, let's once again look at an example of how that's done. We'll go File, Example, Basics, and this time we'll open up Digital Read Serial. This program reads a digital input on pin 2, which in this case is our button. As you can see, push button is specified as pin 2. Instead of setting the pin mode to output, it's set to input, and instead of digital writing to the pin, we now digital read. Once again, we don't expect you to be programmers, so I'd recommend copying the necessary code over into your program. So for example, let's get this, paste it up at the top. Let's grab this pin mode command, put it in our program. Once again, in void setup where it was over here. And let's take this code to read the input pin. Pop it into our void loop. Alright, taking a look at this code, we've now modified the program so that we can read the digital input from the push button. However, we're missing one key step. We don't do anything with that information. If we look over here in Digital Read Serial, you can see that they print the button state to the serial monitor. And if you run this program, you can see that happening by opening the serial monitor here. However, we want to do something to the LEDs with that information. So something that's a little bit more advanced is to know that high is the same as 1 and low is the same as 0. This makes sense if you think about on or off. On would be 1 and off would be 0. So we can go ahead and change that in the code. Now, when we run this digital read command, either the button state is going to be pushed, which is 1, or not pushed, which is 0. So what we can do is, instead of writing a fixed value to the LED, we can change it to write whatever the button state is. We can do the same here. So now, with this code modification, when the button is pushed and this code runs, the LEDs will turn on and off in an alternating fashion. But when the button is not pushed, the LEDs will remain off.
Now that we've modified the code, let's go ahead and upload it and check that the button works. So as expected, now that the code is finished uploading, nothing is happening, and it shouldn't until we push this button. Then when the button's held down, the lights alternate until the button is released.
Alright, so now we've seen one way to use the state of the button to modify the behavior of the LEDs. Let's look at another. So first I'm going to go ahead and undo some of the changes we've made. Get us back to where we were digital writing either high or low to the two LED pins. And now I'm going to show you a way to control whether or not this code runs at all based on the state of the push button. So what we're going to use is an if statement. And there's tons of examples of this online that you could use and copy to figure out how this would work. I'm going to go ahead and give you a quick example. So what we want to do is if button state equals, the double equal is used to compare two things, 1. So if the button is pushed, and then I'm going to make a squirrely bracket and a closed squirrely bracket here. And now all this code between the squirrely brackets will only run if this condition is met. So what we'll see happen is when the button is pushed, the LEDs will begin to flash, and then when you let go the button, the LEDs will stop flashing and will stay in the last state written. Namely, they'll stay with this state.
Now that we've finished modifying the code with the if statement, let's go ahead and upload it and see what it does. As expected, nothing happens at first. Now let's push the button and see the LEDs begin to flash. Now we release the button, we can see the code within the if statement stopped running and the LEDs are left frozen where they are. We've now completed the circuit for our sign, but there's a problem. Let's say I'm done programming the Arduino and unplug my computer. It's dead. Now, we must power the Arduino off something other than the USB port. How do we do that? We use a 9-volt battery. Connecting the ground wire on the battery is easy. It goes straight to ground on the Arduino. The one issue you'll face is that the wire end is really short, so you can't plug it directly into the Arduino. Instead, we have to connect it to a place that's grounded on the breadboard. For example, this first row. The power wire is slightly harder. Some of you may have noticed that the Arduino power supply is 5 volts, but this battery is 9 volts. How do we deal with this? The answer is there's a special pin on the Arduino called VIN. This pin is designed to take power from a power supply and convert it to the 5 volts that the Arduino needs. Once again, we can't plug this wire directly into the VIN plug because it's too short, but we can put it on our breadboard and then run an external wire, such as this one, from our breadboard over to the VIN port on the Arduino. The moment we plug this in, our Arduino will turn on and our program that we uploaded last will begin to run. As you can see, the moment I push this button, the LEDs begin to flash.